Solve the system by the elimination method. Negative 2x plus 5y equals 14. 7x plus 6y equals negative 2. To solve a system by the elimination method, we want to eliminate one of the variables when we add the two equations together. To do that, we want the coefficients of one of the variables to be opposite. Notice that the coefficients of x in each equation are opposite. And so let's multiply the first equation by 7 and the second equation by 2 so that we eliminate x when we add the equations. Multiplying the first equation by 7, we have negative 14x plus 35y is equal to 98. Multiplying the second equation by 2, we have 14x plus 12y is equal to negative 4. Now we add the two equations. Negative 14x plus 14x is 0. We've eliminated the x term. 35y plus 12y is 47y, which we have is equal to 98 minus 4, which is 94. Now we divide both sides of the resulting equation by 47 to find that y is equal to 2. Now that we've found y, we can substitute 2 for y into either of the original equations to solve for x. Let's choose the first equation. We have negative 2x plus 5 times 2 is equal to 14. Simplifying, we have negative 2x plus 10 is equal to 14. Subtracting 10 from both sides, we have negative 2x equals 4. And dividing both sides by negative 2, we have x equals negative 2. Therefore, we found the solution, negative 2, 2. We should always check that our solution does satisfy both of the original equations. Looking at the first equation, we have negative 2 times negative 2 plus 5 times 2, which is equal to 14. Using the second equation, we have 7 times negative 2 plus 6 times 2, which is negative 2. Therefore, the solution does satisfy the system, and so our solution set is the set containing the ordered pair negative 2, 2.